Hi, and welcome to the 2018 Paper 1 of the Junior Cert Higher Level. This is question 2 we're looking at. So, as usual, if you want the notes I'm working off, then please send me an email at shanetroy@gmail.com. That email should be in the description below. So, question 2 here, now I've basically screen grabbed the two parts of it, so it would look very different in the actual exam paper. But part A here says that Phil is an athlete. The graph below shows the number of calories in calorie, is the unit, she burns per hour, depending on her average heart rate. Note the axes do not start at 0, 0. Okay, so that is not the origin. Okay, it's kind of a zoomed in on that part. Okay. We have our y-axis of calories burned per hour, and we have our average heart rate. Okay, so you can see as the heart rate goes up, the number of calories being burned increases. Okay, that makes sense. Now part 1 then says use the graph to estimate how many calories Phil would burn in 1 hour if she had an average heart rate of 170 beats per minute. Okay, now we're using the graph. Okay, we don't need to calculate it here. It's just testing our ability to read graphs. Okay, understand. Now, before we do anything, we should mention that this is a linear equation, or this section of it anyway is linear. Okay, so if this ever comes up to talk about slope, which I should see down here from just a hint I've given, it will. Now we can find the slope of this by getting the rise over the run. So if I take let's take from 400, okay, from this part here and this part here, so that little segment there, any triangle will give you the rise there is 100 calories. Okay, it's supposed to be a 0, apologies. And the run here is going from 135 across to 145, so 10 beats. Okay, so rise over run, 100 divided by 10 would give you a slope there of 10. Okay, now that might not be, I'm assuming we need it later on, but anywhere I pick, make a triangle, even big triangle like that, if I work out the rise over the run on that bigger triangle, it should be 10 as well. Okay, so the slope there is constant. I'm going to remove that stuff there just to clear it up for us. Now, if I look at here, I'm looking for 170 beats per minute, which is, I can find it there. And once I put any marking there or something to make it obvious that I've seen the 170, I should be getting some marks, okay, for an attempt. But we basically, it's always the graph that matters. Everything else is just an XY diagram. This heavy line is all that matters. So the thing we're asked to look at now using a ruler, okay, or bring it up in a straight line to touch the graph, then read off its corresponding reading, which should be the 700 to 800, 750. Okay, so calories burnt in 1 hour should be 750 calories. Now the answer done on the next page, I'm going to go to that. Okay, so that was part 1 there. Now part 2 says use the graph to work out Phil's average heart rate when she burns 300 calories in 30 minutes. Okay, so the answer there, now 300 calories in 30 minutes. Remember, our unit is calories per hour is the same thing as 600 calories in 1 hour. Okay, just doubling it. So if I find where 600, another graph here, if the line is not quite on it, but 600 calories coming across, hitting the graph, drop it down. I'm going to estimate that about 155 beats per minute. Okay, so that's part 2. Now part B here, it's worth 10 marks, so it's just a table. We're going to try to fill it in. Usually, well, it's almost always, when they have a table, they've done one of the calculations. So you can see there, okay, whatever's happening, first one is 60, then 50. Usually they have added them together, give 110. Then the second run here is 60. The numbers are changing here for the sprint. And then you got the 60 and 160. 100 is 160. So you can kind of see there's a pattern going on here. Okay, this is constant, no change. This is going up by 50 each time. Now, I'm just kind of, I suppose if I cop that, why not add in 50? Okay. Now that should be enough. It's correct route of work to at least get me the low partial here, the 2 marks. But let's read what's going on and actually figure it out. Phil runs a series of stages. in each stage she runs a slow run of 60 meters and then a sprint. In each stage after stage 1, she sprints 50 meters more than she did in the previous stage. That's the sprint here, so it's going up by the 50 meters. Okay. Now we've identified that and we've linked it, so no partial 2 should still be in play. Complete the table below showing the distance that she runs slowly and the distance that she sprints in each stage, as well as the total distance per stage. Give the values in the last row in terms of n, so in a general sense, where appropriate. I'm just going to go straight to the answer because it's hard to write with this thing. So we had there the first 60, 60, 60, 50, 110, 60, 100, 160, 60, 50. Now that's when it stops what they've given you on the original question. You've added them together to give the 210. Now our fourth stage is 60, so that's constant. It's going up by 50 each time, so it's 200. So the combined result there is 260. Then the fifth stage is 60, which is constant. Going up by 50 again, so it's 250. Combine them together, you get 310. So how do we say that what's happening in a generalized sense? Well, it's always going to be 60. That's constant. It's 50 meters by the stage number. Okay, now that holds. 50 times 1 is 50. 50 times 2 is 100. 50 times 3 is 150. So whatever n is times the 50 will give you the sprint distance. Now, how do you get the combined result? Just adding them. So 60 plus 50n gives me my total distance for each stage. Okay, that's it. Now, part C here is a little bit trickier. Okay, there's a lot going on here. In one of the stages, Phil runs slowly for 60 meters at 2 meters per second. Okay, and then sprints 150 meters at 7.5 meters per second. Now we know which stage that should be, okay? It should be stage 3, okay? So I'll write that down there. Again, you're always trying to get something. Once you have something, you can try go and hit the full marks. We've identified the stage 3 that may or may not, be useful, okay? We're asked to work out Phil's average speed for this stage, and the units are meters per second. Okay, there's no conversions, everything's in meters. So we should be pretty cool there, okay? Now I'm going to go to the answer because this is tricky, okay? And I've put in here something we need later on is the speed, distance, time triangle. So speed can be calculated by distance divided by time. Or you can look at it from this perspective, time is equal to distance divided by speed. Or distance is equal to speed times time. Speed multiplied by time. Now, I'm making sense of it, but the first thing I'm doing is I know how far they've ran, okay? So the total distance ran, okay, so the D here is the 60 plus 150 is 210. Now, if we work out the total time, okay, so we're looking to get this figure. Well, we know that he took 2 meters per second to run the slow run and 7.5 meters per second to run the sprint. Now I've got this formula from looking at it from reverse, so time is equal to distance over speed. So we know that the total time is the slow run plus the sprint time. Now that's also equal to the distance over the speed for the slow run and the distance over the speed for the sprint. Okay, now we have that information. We have distance and speed in the question. So for the slow run, it was 60 meters divided by 2 meters per second, so the speed, plus the sprint was 150 meters divided by 7.5. Now divide those two things in and add them together, and you end up with the time for the slow run plus the time for the sprint. 20 plus 20 gives you a combined 50 seconds. So after all this calculating, we now know that your Phil ran 210 meters in 50 seconds. Now, what's that speed? Well, we can use the speed equals distance over time. The distance was 210, the time was 50 seconds, and that divides into give 4.2, and again, the units are meters per second. It's tricky enough, okay, but if you can get the concept, it's fairly handy, okay, but again, getting the concept is where the trick lies. So that's part C, and that should be the end of question 2. Okay, it is, and thank you, and see you on question 3.